sorry for the music lovers out there. I am not a violinist. I am a final year mechanical engineering student. I got an interesting stuff here. I am not a player of the violin, but I am the maker of the violin. Yeah, you heard me right. I made this violin. Hey guys, welcome to my YouTube channel. I am NIRMALKUMAR and in this video I will show you how I made this violin. So now I will explain you how a violin works. A violin is a string instrument. Basically violins are available in the market on two different varieties like acoustic violin and electric violin. This is actually an acoustic instrument. In this violin you can see this has its weird looking body shape, which is actually called the sound box, which means this is the actual amplifier of the violin. When we play the violin, the string vibrates. The vibration from the string passes through the bridge to the top plate. Below the top plate there is a sound post. From there the vibration passes from the top plate to the bottom plate, which makes the entire body of the violin, which resulting in the sound which we hear. And when we talk about the electric violin, which doesn't have this sound box, which means they need to be connected to an external amplifier in order to be heard in our human ears. So why in the first place did I make this 3D printed violin? I want to answer this question. Few months ago I bought a 3D printer for me and tried some of my own designs and got successful results. Then I decided to make something new. Then I decided what can I make something new. Then I got an idea of why can't we make instruments which can be played and which is actually a 3D printed one. Then I got this idea of making a violin, and I will help you how to design your violin, and I will show you how the designing process will take place in this video itself. As I said, I will show you the designing process of the violin. I will give you one example of designing the front part of the violin. I don't want to make this video too long, so that's why I am showing you one example of designing the violin. So the software which I am going to use here is the Fusion 360. Why Fusion 360 means, in Fusion 360 we can use the option of importing the SVG image files. Unlike PNG and JPG, they uses pixels to show the image, but in the case of SVG it actually has the coordinate points. Suppose if you are importing an SVG image having a square of 40 means we are actually importing the sketch of the square, so that means we doesn't need to draw the square again after importing it. So in this case we are going to use this option. So what we need to do is we need to visit the website called Making the Violin. In this website we can find the available templates for making the violin, and all the instructions are given in this website. So if you need to make your violin from wood, etc., you can follow these instructions, and it will guide you how to make a violin from wood itself. But what we actually need here is the template. So we need to download the front plate template here, and when we click the image it opens into the next tab. From there when we right click it, we have the option of saving it as an SVG file. After downloading the SVG file, we need to open the Fusion 360. We need to import it. The import option is available on the top right side of the Fusion 360. When importing it, you can see that we need to click the plane which we need to import the sketch. When selecting the plane, it imports the sketch into that plane. We need to ensure that all the lines are properly closed. When we converting something into an SVG file means there are many possibilities of having broken lines and unwanted lines. We need to delete all these, and we need to close some of the lines which are not closed, etc. We need to do some of the manual works. Then we can utilize it. When we see the front plate of the violin, it is actually not a straight one, it is actually a curved profile. So we need to create 5 planes at proper distance. This distance can be taken from the templates which is available in the website. So we need to draw the 5 planes, and we need to draw curvatures in each of the planes which we created. We need to ensure that the starting and the ending point of all 5 curves on all 5 planes need to be aligned properly So their height can be differ from one another, but all the curves need to have the same starting and same ending point. What I'm trying to say is, if it doesn't have the same starting and same ending point, means after we create the front plate, means the bottom of the front plate will not have a proper flat surface. I believe what I am saying can be properly understood by you. So all the 5 curves need to have the same starting and same ending points. So after creating these 5 curves, we need to use the loft command in order to make the surface, and after creating the surface, we need to use the sketch to make a extrude cut. Then you will get the front plate shape. After that, we need to convert this surface into a solid model. So we need to use the command called thicken, and we need to give the proper thickness which we need. So this will convert the surface model into the solid model. Then we need to cut the F-holes. We can use the same sketch which we previously imported. We need to select the F-hole profile, and we need to make the extrude cut. That is how you can design the front part of the violin. The same thing goes for the bottom of the violin. Unlike the template and the curve value changes, and the ribs also same, and for the entire process of the violin, the templates are available in that website. You can utilize it and you can design the violin. I hope you would have got a proper understanding of how to design the violin by yourself. Now let's see the video clips taken during the printing process of the violin, and after that you will see the video of me explaining the 3D printed parts of the violin. Alright guys, now I will show you the 3D printed parts one by one so that you can get a clear understanding on how to assemble your 3D printed violin. So the first part is the front plate. You can see that I used masking tape to hold it. These are used temporarily to hold it, to give a clear understanding for you how the end product will look like after the printing process. See, I splitted this front plate into 3 separate pieces, 1, 2 and 3. This is the top, middle and the bottom. And after printing the middle piece, I experienced support failures because of this F-holes. So in order to print this F-holes clearly, I again splitted the middle piece into 2 separate pieces. You can see there is a gap in between the middle piece. So the front plate is actually divided into 4 pieces, the top and the bottom, and the middle part is subdivided into 2 pieces. And all the prints which I printed are placed in the vertical direction. See, this part is printed with this is placed vertical in direction so that you can get a quality print. The next one is the violin ribs, and the next one is the back plate. You can see that this back plate is divided into 5 pieces, 1, 2, 3, 4 and 5. The reason why here it is 5 because my 3D printer doesn't have pass and resume option. While printing this bottom part of the back plate, power cut happened and the print stopped at this stage. So I grabbed my Fusion 360 and splitted the file and printed this part separately, and I want to stick it again. If you are doing it in your 3D printer, I suggest you having a power supply or a UPS for your 3D printer in order to help you during this unexpected power cuts. And the next one is the bass bar. This bass bar goes right next to the F-hole in the top plate. You have to stick it here by providing some supports. So I will show you the assembly process one by one. So this is now just understanding purpose only. I am showing you the parts, and this is how the violin body will look like after you stick them together. And the next one is the tailpiece. This is also 3D printed. It is used for holding the strings. And the next one is the handle of the violin. See, this is also a very long print. I splitted them using Fusion 360, and especially I splitted these parts because I made them print in a way that I minimize a lot of supports. So you can see these kind of scrolls cannot be printed in the vertical direction because this needs a lot of supports, and print failure can happen at any time. We cannot judge. So I splitted this scroll into these 2 parts, and I printed them one by one by placing them horizontally. And this is the handle of the violin. You can clearly see this. The next one is the fingerboard. This is also split into 2 parts. This goes right above the handle of the violin, and you have to stick these 2 parts into one. And the next one is the sound post. This sound post is placed inside the body of the violin using this sound post tool. This sound post tool needs to be setted because it is not a straight piece. You need to bend it. I will show you how to use it. And the next one is the saddle post. This is the place where the tailpiece of the violin is held, and the tail knob. This is also a 3D printed one, and the violin bridge, which you can see, and the violin pegs. So after printing your 3D printed parts, you may wonder how you are going to join them. See, there are many good methods of joining the PLA parts. It's like using an adhesive, plastic welding, or using the chemical solvent method. When speaking about adhesive, it is like using super glues like Ca cyanoacrylate. It forms a strong bond between the separate pieces of the PLA by joining them. Like if you apply super glue in between them, it forms a bonding between these two pieces and held it firmly. You can use super glue like this one. This is Anabond. It's cyanoacrylate. You can see, you can get this from your carpentry shop. This is one of the safest method which can be used by any individual in their home itself. The next one is the plastic welding. All you have to do is, if you are going to join these two separate pieces using plastic welding, means you have to melt these surfaces and you can join them. But if you prefer about the surface finish and close tightly spaces, then this method cannot help for you. And the next one is, you can also use 3D print, which uses the same filament which you make your 3D printed part. It just melts the filament in between the gap spaces you have provided, and it forms a strong bonding after it cools, so that it becomes one piece. And the next one is the chemical bonding method. In chemical bonding process, we use chemicals that eat through the bonding edge of the PLA material and melts them, and allowing them to cool makes them into one single piece. And some of the very common examples that you can use for this chemical bonding method is the 3D glue, and it's very a good product to purchase because it has a lot of good reviews. It is a combination of a solvent with PLA filament in it. After you apply it to the mating edge of the parts which you want to join together, it forms a strong bond which is really strong to break. And the next method is by using dichloromethane. It is very thin, it is volatile, and it forms carbon monoxide in the air. If it's not handled properly, it gets into your skin and enter into your bloodstream. It is a carcinogen. It can make you get cancer easily if you didn't handle it properly. A proper gloves, eye protection, well ventilated area, and proper training should be made while using these dangerous chemicals. I won't suggest anyone to use these kind of dangerous chemicals, but these chemicals are used in conditions where if you are gonna join those two pieces in a tight space, and if you are considering aesthetic appearances like no gaps, etc., in that case these dangerous chemicals can be used. It can also be used for smoothing and surface finishing operations. All you need to do is to just pipe it a little bit of dichloromethane on the surface which you need to smooth it. But again, I tell you, this is one of the dangerous chemical. In my case also, I purchased it in very limited quantity, 100 ml, and I think this is more than needed for my project. If you are gonna make PLA filaments means you can use cyanoacrylate. I can show you an example here. You can see these are the two failed prints. I joined them using an adhesive. This is joined using cyanoacrylate, that is super glue, and you can see that this is very hard to break. You can see there is no movement in the place where I used the super glue. This and this are two separate pieces. You can see no matter how much I twist it, it didn't give any movement. It breaks at one point, that is not even glued. So cyanoacrylate is more than enough for joining PLA parts, and don't risk your health by using these kind of dangerous chemicals. So now let's talk about the assembly process of the violin. As I said earlier, I used the DCM to join PLA parts. By means of capillary action, it passes through the gaps of the PLA material and melts them and forms it as one single piece. These are the images of the back plate taken after joining them using DCM, and these small pins helps you to align them over the ribs as a guide points. And these are all the images taken after joining all the parts. It took me nearly 6 hours to completely join them. As I was doing these things by myself alone, it was difficult for me to take video clips because I need to use proper mask and gloves while using DCM, and mobile screen touch is not working while using the gloves, so I took pics. After finishing the process, I noticed something which I made wrong. Actually, I placed the bass bar in the wrong position. It is not how it's supposed to be placed actually. Then I reopened the violin, and this time I marked the position for placing the bass bar correctly, and the sound post position is also marked by making proper measurements. Usually the sound post sits in between the top and the bottom plate near the left leg of the bridge. These measurements are properly marked. These measurements are actually taken as a reference from the templates available on the Making the Violin website. You can also visit to the website and make your own reference point. This time I used to glue the sound post on the top plate of the violin using super glue, making sure it is straight. This is not how the sound post is supposed to be fixed, but in my case the surface of the PLA parts were too slippery and I don't want to myself getting too frustrated, so I glued it on one side, and you can see these are the guide pins will help you to join the top and the bottom plate, but while removing for rework this got damaged, and you can see this is how the sound post is supposed to be look like inside the violin, and with the help of the sound post tool I am moving it a little bit, making sure it is straight and held firmly. And while talking about the bass bar, while placing the bass bar I had some of the gaps in between them. To fill those gaps I used failed PLA prints and sanded them and collected the PLA dust. I sprayed the PLA dust over the gaps and applied a small amount of DCM using paintbrush, and then the gaps are filled. So this is how I have done the rework process, and now you can see the results of the rework, and these are all the results of the rework. And then after finishing this rework, I decided to give them a paint look. I agree that the color of the black was actually great. This I regretted after finishing it later, but in my opinion the black color was actually great. I used enamel paint here, and these are the results of the violin. You can see after finishing them. So we are done with making the violin, and seeing all of your interesting faces tells me that you all are eagerly waiting to see the sound of this instrument. So we are here to check the sound of this instrument by playing it. Don't worry, I won't bleed your ears now by playing this violin by myself. At the same time, I won't disappoint you by sending you without listening the violin play. What I actually did is that I gave this violin to a violin player and asked to record the violin play. So I will be attaching the clips of the violin play which you can hear and enjoy. And I also want to mention you one thing, that there is no active pickup or any kind of pickup used while recording the violin play, because the video clips which I have attached is a cropped one showing the violin only, because I can't show the violin player as it is a request from the violin player. So I want to mention that don't think that there is any pickup which is used while recording the violin clip. You can still hear the external disturbance noise coming while recording the violin, and the sound of the violin which is recorded using only the mobile phone only. There is no super camera or professional camera which were used while recording this. It was taken using a normal Android phone only. So you can get a clear understanding of how the instrument sounds like in both indoor and outdoor conditions from the video clips. So enjoy the music. I hope you would have enjoyed the music and would have got a proper understanding of how the instrument sounds in both indoor and outdoor conditions. Now let's talk about what are all the issues which I faced and the problems which I encountered during making this violin. If you are making a 3D print, especially for strength related operations and application oriented means, there is a lot of parameters and factors which needed to be considered. For example, consider two rectangles. The rectangle A is printed using horizontal orientation and the rectangle B is printed using vertical orientation. These two will have different strength properties because of the change in orientation. Because when the rectangle is printed on this orientation means the layer lines are formed in this direction. If the rectangle is printed on this orientation means the layer lines are formed in this direction. For example, if the rectangle A which is printed in the horizontal orientation and the rectangle B is printed in the vertical orientation. If the rectangle B is placed here and the force is acting on this direction, so the layer lines are in this direction. So the force which is acting here have the higher possibilities of breaking this rectangle easily at this point, because it will bend like this and it will easily break at this point. But if the rectangle which is made in this orientation will have layer lines in this direction, when the same force is applied on this point means it will elongate much more than the previous rectangle and it will not break as easily than the previous rectangle. I can show you the real example which I faced in this project is the neck of the violin. Actually, the neck of the violin which I printed is using the vertical orientation. So you can see that the strings are coming from this side to this tailpiece. So you may not believe that the force which is acting on the top of the violin is nearly 20 kgs because of the string tension. So due to this, the strings are pulling this neck on this side, so which means this neck is flexing like this side. So you can see it actually broke at this point and also on this point also. I glued it here. What I am trying to say is the orientation makes a lot of thing and it affects and also improves the strength of the 3D printer. So orientation makes a lot impact. And one more example for this orientation is also I can show you another example which is also I experienced in this project. That is printing this tailpiece. Initially I printed this tailpiece in the vertical direction. So I printed this tailpiece. When something is printed in the vertical direction, the layer lines are formed in this orientation. This tailpiece is experiencing elongation tensile load. So you can see the string is pulling this tailpiece. So the layer lines are formed in this orientation. Due to that, this got easily ripped apart. But this tailpiece is printed using horizontal orientation, which means the layer lines are formed in this kind of direction. So it is working properly than the number of days which this tailpiece held in that position. So what is more noticeable thing is, before making this tailpiece, I made this tailpiece, but this actually got failed nearly the finishing point. So this was useless and I broke it by myself. This one was broken during application, and while I am comparing these two, at a sudden I got noticed that these two got broken exactly at the same point where the second tailpiece was broken during the application. So the application shows that the orientation plays a lot of impacts in the strength of the 3D printer, and the infill is also playing a major role in the strength of the 3D print, like the type of infill and the infill percentage. If you need a higher strength, means you can use gyroid infill. It uses less infill and gives high structural strength, and there are so many other parameters like wall thickness and so on. If you are using less infill and printing or 3D printed parts, means don't sand your 3D printed parts, because you will thin the walls and it will easily get broken. My primary goal before starting this project was to minimize the material as possible as I could, so I used vertical orientation, and the entire project of making this violin took me around 700 grams. But if you consider about strength for your 3D print, means you need to use the different orientation. Mainly you need to consider that the direction of force must be perpendicular. It depends upon the parts to part, but mainly consider the high stress area and the low stress area. And there are also many other materials which are available for 3D prints. If you are making 3D prints for just for showcase purpose, means you don't need to worry about these kind of parameters and factors. But if you are making 3D prints for strength related operations, means you need to definitely consider these are the things in your mind before getting started. I hope you enjoyed this video. This video might be too long, but need to cover some of the important points during this project. I hope you guys would properly got a clear understanding about this project. Thanks for watching this video. If you find something useful and something informative in this video, you can consider liking this video, and you can subscribe to my channel so that I can post regular new interesting stuff. You can watch it at anywhere in your devices. Thanks for watching this video and have a good day, and you can also follow me on Instagram, which I will link in the description. Thank you.